plus 2y minus 8 equals 0. There you go. That's your general form. And now I think about it because I did the homework earlier today. I believe that when I did the homework, I always moved that constant to the other side. That was just a force of habit. It doesn't matter for me which way you do it. You can leave it equal to 0, or you can move that constant to the other side. So really, if you're trying to explain to somebody how to get from standard form to general form with the circle, you just say what?
Expand.
Just expand out your factors here. Expand that out, expand that out. Once you expand that out, you're done, right? How about the other way?
Going backwards to happen.
Yeah. How do we get from here back to that? Okay, so let's say I give you this right now. I say, hey, that's a circle, okay? I want to know its center and its radius. You're going to go, shit, right? Because it's not obvious, right? From this, it's obvious what the center and the radius is, right? But from here, it's not obvious. So how do we go backwards? Let's do it. Let's see. Everybody paying attention? This is an important part right here, all right? This is a good type of test problem right here. Because everything else we've done up to this point is pretty straightforward. There's not a whole lot of deep thinking that we've had to do at this point.
You first just rearrange by going x squared minus 8x into y squared.
Okay, so you're saying kind of like get your x's together, get your y's together. I'm okay with that.
You can rearrange it and then you can visualize it easier.
You can
compress it.
Okay, so how are you going to compress it?
Do factoring.
We'll see. We'll see if anyone else knows where I'm headed with this. Anybody know where I'm headed? See, what we have to do is we have to go from here, right, back to this step. This is really, there's nothing that happened here really, but we've got to go, this is the hard part, right? How do we know that this -8 came from a 17 and a 25, right? How do we know that? Do you see what I'm saying?
Oh, well, don't we know what the radius was?
No, we don't know anything. We're starting with this.
That's the problem. You don't know.
You don't know, right?
Yeah, you can't extrapolate that.
It's not obvious. Does everyone appreciate the trouble we're in right now? Yes? Okay, there's a way around it. And what we're going to use here to do this is your favorite thing. We're going to complete the square.
I fucking knew what I should have said.
Well, you were trying to say it by saying compressing.
Well, I said compressing, but then when you were like, how would you go further? And I saw the -8, I was like, it's completing the square. But I didn't want to be wrong, so I didn't say it.
Okay. So how do you complete the square? Okay, look, everybody in here has to know how to complete the square, all right? And if you don't, it's okay. We're going to do it right now, all right? But this is a very important process that you need to learn. So I'm going to do it on the side here, and then we'll come back to this. When you complete the square, what you do is you need to have a quadratic term and a linear term of the same variable together like this. And if there's numbers in here like that, don't even worry about that. Just look at your quadratic and your linear together and write them down. Make sure it's in descending order, which means highest power of x down. Right, don't write it backwards because then this isn't going to work. All right, next step, very, very important step. In order for completing the square to work, the coefficient on x squared must be 1. If it's not 1, you actually have to factor out something. Now, I don't think you're not going to see it in your homework, okay? That's not going to happen. But in Cal 2, it happens. So when you get to Cal 2, if you're not familiar with it, you're like, what just happened? All right, so always make sure that this is a 1 right here. I'll show you an example if we have some time of what happens if you have something other than 1 out here. Okay, it's got a 1 in front, descending order. Now, we're going to do a little weird stuff over here. We're going to look at the coefficient in front of x, write it down, and we're going to divide it by 2. Why 2? Because this is the way we do it, okay? It's always divide by 2. There's an algorithm that we're following here. Okay, it's not like, okay, I'm dividing by 2 because there was a 2 over here. No, it's every time you take the number in front of this variable and you divide it by 2. And that gives you a number, right? That's -4. I like to box that number because I'm going to need that in a little while. Then I'm going to take that number and I'm going to square it. Why? Because it's part of the algorithm. You always take this result and you square it. So square it, you get 16, right? How many of you have seen something like this? Or this ring a bell? A little bit? Okay. Okay.
B over 2 squared.
What's that?
B over 2 squared.
B over
That's right.
2. Yes. Uh-huh.
And then there's a reversal of that 2 where you have -2 over B.
Here's the part that I think is really, I'm going to try to see what you learned, okay? Anybody know what to do with that 16 now?
Yeah, you add it.
Add it?
You have to add it and subtract it.
Okay, so I've heard you add it and subtract
You're
it.
gonna block it off, and that's going to become your new coefficient on the end. It's going to become your C term.
Okay.
And then you also have to subtract it from where you drew your parentheses. When I do the exclusion, I don't go across the parentheses. I don't go across the equal sign.
But I want everyone to, because we need to decide which way is better. One way is we're going to add it and subtract it. The other way I heard, I think, was add it to both sides. How many of you have heard, like, you take that number, you add it to both sides?
Well, what I would have done is I would have first taken the.
Well, hold on. I'm asking, have you added to both sides or no? Yes? Add and subtract. How many of you have heard add and subtract? Okay. Add and subtract is the way to go. All right? Because in Calculus 2, you have to do this, but you're working with something that doesn't have an equation. So you don't have two sides to add anything to, which means you have to be on the same side, which means you have to add and subtract at the same time. Now, if you've never seen add and subtract, I'm going to explain it, and it's pretty, I think it's pretty cool. So look, see this expression right here? Or I'll keep working with this. I'm going to take x squared minus 8x, and here it comes. I'm going to add 16 and subtract 16. Now, am I allowed to do that? Well, what is 16 minus 16? 0. So am I really changing the problem? No. But I'm being clever, and it's going to work. When you do this, the first three terms are guaranteed. If you did all this right, those are guaranteed to be a perfect square trinomial. It'll be something in parentheses, right? Squared. It'll be x, and then you said minus 4, right?
Yes, sir.
The minus 4 you could just get from looking at this, but you can also come back. Remember I boxed this number right here? You can get it from here also. So x minus 4 squared. That's the first three terms. But you still have minus 16, don't you? All right. Now, I'm going to do the same thing. I'm going to do the same thing on this one. All right? So I did it for this one. Now I'm going to do it for this one.
And I can already see this.
So I'm taking y squared plus 2y. That's all I'm looking at, right? I take the number in front of y and take half of it. That gives me 1. Then I'm going to take that number and do what with it? Square it. And that gives me 1 again, right? I'm going to take this 1 and I'm going to add and subtract it to this. Then the first three terms, I'm going to have to continue this up there. The first three terms are guaranteed to factor to be y, then something squared. And what's that something in there? 1, right? But I should put plus 1 because it needs to be two terms. So plus 1. And then what's still there? Minus 1. Don't forget that minus 1. All right? So now I can come back here and I can continue where I was, right? I'm going to erase this. And I know that these two right here became this, right? So I have x minus 4, that quantity squared, then I had minus 16. And then I have these two terms, which became this, right? So plus parentheses y plus 1 squared minus 1. Then what do I still have there? minus 8 equals 0. Now get all my constants and let's move them all to the other side. So take that, take that, take that, move them all over there, and we should get, yeah, what we had started with originally when we first, was it 25? Okay. And from that you can easily see what the center and the radius is. So you should be comfortable going from general form to standard form and standard form to general form. Standard to general is easy, just multiply out. General back to standard, a little harder. Would you agree? A little bit more involved there?
More steps.
Yep. Any questions on that? Okay, I have enough time to talk a little bit more about the completing of the square. Because this really will get you in Cal 2. How many of you have to take Cal 2? Yeah, it's enough of you. So, all right. So what if I had this? 3x squared plus. I'm just trying to think of how ugly I actually want this to be. Well, let me give you something that's in line with what you would see in Cal 2. I don't want to baby this down. All right. So let's complete the square on this. The goal of this is to turn this into that. And believe it or not, in Cal 2, you need to be able to do that in order to solve a problem. Like the quadratic form right here is no good for what you're trying to do. You need it to look like that. So you just have to trust me that this is needed, all right? All right, so when I say you complete the square, you're supposed to look at these first two, right? You can ignore the 4 and look at these, make sure it's in descending order, and then make sure that that's a 1. Right? It's not a 1. So you're going to factor out a 3. But this is not a multiple of 3, but who cares? We can still factor out a 3, can't we? That just becomes 5/3 x. Now you need to be able to see that step because it's the same problem, isn't it? Distribute the 3 through. That becomes 3x squared. The 3 comes over here, the 3's cancel, and it becomes 5x, right? So everyone agree that's the same thing?
So why didn't you 3 distribute on the 4?
I could have done the 3 out here, put a parentheses here, and made that 4/3. I could have. But remember with completing the square, all that you're really concerned with are these two guys. Because you're going to get a constant that's going to spit out of this, and it'll just join the 4 later. So I just keep it on the outside. You're good? Okay. I recommend you do it this way. I wouldn't mess with that 4 at all. Just keep it out there. All right, now you can do completing on the square, and this is what you're working with right in here. The 3 we'll have to keep track of, but for now, let's look at that. So I'm going to take the number in front of x, which is 5/3, and I'm going to divide it by 2, which is the same as multiplying by a half. Boy, and you know what? I've kind of uncovered a little can of worms here. Or opened a can of worms, sorry. What is this? This is what I call bad notation. This is horrible notation.
You can't see the distinction in the line.
That's right. You can't make a distinction between what's being divided by what. That's why some division bars are longer than others, because you need to be able to make that distinction. This division bar is intentionally longer so that you know you're taking 5/3 and dividing it by 2. Here, you could be taking 5 and dividing it by 3/2, or you might think it's 5/3 divided by 2, and they don't give you the same answer. So you have to make a distinction. So this is bad. We're taking 5/3 dividing by 2. I'm going to write 2 is 2 over 1, and then division is multiplication of the reciprocal. So this really becomes 5/3 times 1/2, which is really 5/6. So this is 5/6. That's that first kind of magic number that I'm going to need. And then square that. So I'm going to take 5/6 and I'm going to have 25/36. And that's unfortunately what I've got. I've got to work with that. So I'm going to take that number and I'm going to add and subtract it. Where? Behind the, out here?
You're going to subtract it, you're going to subtract it from behind the parentheses, you're going to add it from inside as the C term.
What do you mean? I didn't follow you there.
536, it will become a C term, added inside the parentheses.
Inside the parentheses. Add it.
Outside of it, it will be subtracted.
That's not going to work. Watch. This is where you should put it. Here's another way I want you to visualize this, because yes, but I think it's easier if you just try and visualize it this way. Look, everybody agree that right next to that is a 0? Does everyone agree that there's a 0 there? Right? There's a 0 everywhere, but that's a very clever place to put it, isn't it? Because I can replace that 0 with this minus itself, but it would need to be inside that parentheses. So I'm going to do that on the next line. Equals. Three parenthesis x squared plus 5/3 x. I'm adding 25/36. I'm subtracting 25/36, closing my parentheses, and then saying plus 4. Y'all buy that? This is why I was saying, how many of you have learned where you get that number and you add to both sides? You see how, I mean, in this problem, you don't have both sides. And even if you did try it, like, I think there's going to be some major problems when you try and add it. It's just, I've seen it in my calculus class. I've seen it happen. It's just, the method kind of falls apart. So we're good up to this point? The first 3 terms here should be a perfect square trinomial. But we've got a bunch of other parentheses and stuff to be careful with here. So watch, I'm going to be very careful with my parentheses. I have a 3. I have a parentheses, right? I have another parentheses back here, but these 3 terms become that, right? And what is that thing inside there with the x?
5/6.
It was 5/6, right? Positive? But what's still in here next to this big thing? Minus 25/36. Close it now, plus 4. Still making sense? Now, let's pass this 3 through. This 3, I want to pass it through the parentheses. So what I'm going to do is I'm going to insert it. It's just going to pop out right in front of this parentheses. And then I'm going to pop it right here, and it's going to hit that thing. So it'll be 3x minus, plus, sorry, 5/6 squared minus 25 what? 12ths. So that's just the 3 came in and reduced out with the 36. And then I don't need any more parentheses, right? Plus 4. Questions? Almost done. Just put these 2 together. These are constants, right? Put those together. So let's rewrite this. This is 4/1. I can multiply top and bottom by 12. It'd become what? 48/12. Ooh, 48/12. Put those together. 23/12. So this is equal to 3 times x plus 5/6 squared plus 23/12. we've completed the square. All right, so if that made you feel a little uncomfortable, that's okay, if it made you feel uncomfortable.
So that was a 4?
Uh,
Took 4 over
4.
1, and then he
Oh.
multiplied both sides.
Yeah, rewriting that to get a common denominator.
To a factor itself.
All right. Good? Feel okay? All right. Well, this is our first day. It's 2:20 right now. We've got 20 minutes left. You want to play heads down, thumbs up?
Sure,
I missed that game. I just want to play it one more time. How many of you have played that? Yeah? Wasn't that fun?
yeah, it was great.
Lay down in class and your classmate comes in, puts your thumb down. If you've never played it, you missed out on life. You really did. All right, so I'm not going to have very often time in this class to kind of give you random not useless information, but just kind of random information. But I'll take maybe 10 minutes, give you some, what I think is pretty cool stuff, not really related to this, and then we'll cut you loose, all right? And when we come back next time, we're going to start the next section. Where's that sign-in sheet? Did it get around? Everybody got it? You do have homework tonight, okay? Do you want me to write it down up here, just so you have it? Remember, this is online. Pardon me? It's on Canvas, but I'll just put it up here. 7, 9, 13, 15, 21, 25, 27, 31, and 39. And remember, I did these problems on video, so, I mean, they're there. All right. So, there's a story that goes with this. If you've seen this, I'm sorry if you've already seen this, but it's kind of cool. The story is that there's a kid, a famous mathematician, who his father was an accountant, and he went on. He did a lot of things in mathematics. You may have heard of solving systems of equations. You use this thing called Gaussian elimination. Okay, so the guy's name is Gauss. His last name, I think his first name is Frederick or something like that. So there's a story, and it's debated whether or not it's actually true. But Gauss is one of the most brilliant mathematicians of all time, so I wouldn't doubt it. So the story goes like this. When he was in like kindergarten or first grade, and this was in the 1800s, he went to school, and the teacher that day presented a problem like this to the first graders. Let's just say that they were first graders. Said, okay, class, what's 1 plus 2 plus 3? You know, so all the little first graders were like, 6, right? He said, okay, so class, today what I want you to do is I want you to add up all the numbers into 100. That was the assignment for the first graders. All right? And they used to write back in the day. Each student like had a little chalkboard, a little piece of slate, and they write with chalk. And back then, when they would write and they would be done with an assignment, they would turn their slate over, they'd cross their arms, and they would just sit there, okay? Because they had like discipline and stuff back then. So anyway, the story goes that within a few minutes, because the teacher had wanted to give this assignment to the students as like busy work, to like let the students like get out of his hair for a while. And
He solved it in like minutes.
yeah, within a few minutes, Gauss turned his slate over, and the teacher went up and turned the slate on the other side and looked at it. Well, he didn't have the answer written down. He had written this down. N times n plus 1 over 2. That's what Gauss had. And the teacher looked at it, and let me explain what the formula is first. This formula will count up the first n numbers. So look, like for this problem right here, if we say n is 3, right? If this is n, then if I plug that into this formula, let's try it. 3 times what? 3 plus 1 is 4 over 2. That gives you 12 over 2. That is 6, right? So it works for 3. That doesn't mean it always works, but it works for 3, right? Well, let's try it for 4. 1 plus 2 plus 3 plus 4. That should be 10, shouldn't it?
Yeah.
Okay. Let's try 4 into this formula. 4 times 5 over 2. It's 20 over 2. That's 10, right? The formula works, and it does. It works. Now, Gauss was not the first person to ever come up with this formula. He was not. The formula was already known. So the teacher gets upset with Gauss and is like, who showed you that formula? And Gauss explained that nobody showed him the formula, that he just came up with the formula. So what I'd like to do is try and show you a way that Gauss came up with the formula. And I think you're going to be blown away at his explanation of this. All right, you ready for this? Remember, this is the goal, all right? Now, since this is a pre-cal class, I'm going to show this to you, assuming that you can get to a certain place here. So let me start with this. Let's call S, which stands for sum, a sum, the sum of the first n numbers. 1 plus 2 plus 3 plus 4 plus, now I don't know where I'm going to stop, right? I'm going to keep going down until I get to n. Do you agree? So I'm going to put n down here. And to kind of help guide you in this, I think on the side here, I'm going to give you an example. 1, 2, 3, 4. Let's say we go to 100, all right? So this is a specific example. This is a general example, stopping at n. So Gauss said this. I could write S down, and because it's addition, it does not matter what order I go in, right? Like 2 plus 3 is the same as 3 plus 2. Order doesn't matter with addition. So Gauss said, I'm going to rearrange it backwards. This is n plus dot, dot, dot. And then what's the last number here? 1, what's the number in front? 2, number in front of that. 3, okay, and it keeps going, right? Yes? I'm going to do that over here so you can see it. 100 plus, the last one would be what? 1. Now, what would be the next number here? 99, right? I'm going to do this one in blue. 99. What would be the number in front of this one? 99. What would be the next number here? 98. What would be the number here? 98, right? Yes? Now, let's see what that looks like on this side. What would be the next number right here? Not n, but what? 1 less than n, right? 1 less than n. So how about I write it this way? n minus 1. What would be the next one? n minus 2. Dot, dot, dot. Yeah? How about up here? What would be this one? n minus 1. What would be the one in front of that? n minus 2. Do y'all see that? Okay, now watch this brilliant thing that Gauss was able to see. What happens if you add these two straight down? What happens if you add these straight down? So what's s plus s? 2s. That should be equal to adding straight down. What's 1 plus n? 1 plus n? Could I say n plus 1? Plus, what's this next one? What's n take away 1 but add 2? n plus 1 again. Plus, what's the next one? n take away 2, add 3. n plus 1 again. Do y'all see that? And does this work the whole way down?
Yes.
It does, because look at the last one. Last one's n plus 1. The one before that, n minus 1 plus 2, n plus 1. Right? Now, over here, what would it have been? 2s, 101, 101, 101, right? All the way down till you get to 101. Agree? So then Gauss said, well, look, this is just repeated addition is the same as multiplication, right? If I say 5 plus 5 plus 5 plus 5 8 times, that's 8 times 5. So this is n plus 1 plus n plus 1 plus n plus 1. How many, careful, how many of these will I have? How many n plus 1 groups do I have? Will I have 1 of them, 2 of them, 3 of them, 4 of them? How many n plus 1s do I have? I have n of them. I have 100 of them over here, right? But in this case, I have n of these n plus 1s, don't I? So he said this right side, 2s, is n plus 1s. And I didn't want, yeah, he didn't want 2s, he wanted s, so divide by 2. So s, the sum we were looking for, is n times n plus 1 over 2. First grade? So this is what separates geniuses from average people. How many of you followed that?
Yeah.
Okay, it's pretty straightforward in terms of, not too bad. The fact that someone could just materialize that out of their brain at a young age, that is genius.
Well, you have to understand, he didn't just materialize it. I mean, granted, he materialized it, but it wasn't, he didn't come up with it on his own. He came up with it because he had previous understanding, because you stated his father wasn't.
I'm not going to let you belittle Gauss at all.
Take away the magic. I'm not trying to belittle. I'm just
You know what I'm saying? Like you cannot. Nobody. Yeah. No. This is brilliant. This is brilliant
It's
stuff.
definitely brilliant, but you take a first grader whose dad wasn't an accountant, and then you take a first grader whose dad is an accountant. It's almost guaranteed that-
He probably had a better chance because his dad was an accountant. Yes. But I'm sure that there was another kid who had an accountant dad who couldn't do this.
Nonetheless,
It's
still awesome.
it is. So that's it. 2:30. You get out early today. We come back. We start angles, radians, degrees.
To show you something else.
Let me turn off my camera.